Welcome to an introduction to Invivo 5 software. This tutorial will provide a foundation to build upon as you continue to grow in your knowledge of the software and its use within your practice. Included within this tutorial is instruction on image manipulation, printing and saving images, creating 2D panoramics from 3D data, airway measurement, nerve canal marking, as well as many other features you will use as you treatment plan. A learning strategy experience that I have seen work pretty well is for you to pause a tutorial as needed and apply the instruction to a case that you have loaded into Invivo. It is also helpful to have the Invivo reference manual available to further understanding. The Invivo reference manual should have been provided to you in digital form when you purchased your scanner. If you did not receive one or cannot locate it, call technical support. When a CBCT scan is opened in Invivo, you will begin in the Section View tab. This tab will be a good place to begin our discovery of the software basics. Section View, as well as all other view tabs, will have the menu bar, toolbar, view tabs, control panel, and a rendering window. All but the menu bar and view tab bar will change depending upon the view tab selected. The menu bar consists of the File, Edit, View, and Help drop-downs. The File drop-down houses Save, Export, and Print functions, Scan and Computer information, and software options. By selecting Preference, you may change background and text colors and measurement font size. You may add your name or that of your practice to the right-hand corner of the rendering window, as well as a host of other functions which we will examine in more detail later. The main features of the Edit drop-down is the ability to undo or redo various actions you may perform as you case plan. Within the View drop-down, you may click on Full Screen to isolate and enlarge the rendering window in all but the Section and Implant View tabs. You may also capture, store, and share screenshots. Lastly, the Help drop-down contains information regarding the current Invivo version and any optional modules installed on that computer. Let's now move our attention to the View tab bar and several of its tabs which will be discussed later in this tutorial. View tabs allow you to perform specific tasks or look at specific subjects of interest. For example, the Section View tab gives you the ability to view axial, coronal, and sagittal images, create custom sections for 2D visualization, and to make distance measurements within the CBCT volume or within the airway. The Volume Render View tab allows for the exploration of internal structures and never-before-seen views of the patient. The ArchSection View tab allows the user to review the image as dentally meaningful perspectives using multiple cross-sections. You may trace nerve pathways here as well. The SuperPano View tab gives you the ability to construct and view an enhanced version of a panoramic radiograph. The Gallery tab will allow you to store and export your images. Located above the View tabs bar is the Toolbar. Within the toolbar are various applications that can be accessed to perform certain functions. Sets of these tools are associated with a specific View tab. Notice that when you hover over one of the icons on the toolbar, a description of the application will become visible. On the left side of the screen is the Control Panel. The Control Panel is the region where patient images can be manipulated and controlled. A control panel is associated with a specific View tab. On the right side of the screen are the first images to appear after a scan is taken. These images are in multiplanar reconstructed format, or MPR for short, displaying the scanned anatomical structures in axial, coronal, and sagittal 2D views. To help you visualize how and where these MPR images derive from, I will turn on the 3D volume view located in the control panel. In the three view windows, we see slices from three anatomical planes in relation to the reconstructed volume. These planes are represented by a different color and will move as the anatomical locations within each viewing window changes. Each view window has multiple contiguous thin slice sections which are interrelational. We can scroll through the entire depth of tissue as the field of view will allow. Axial slices are acquired directly during acquisition. These slices appear in the top viewing window. Our view of the patient is looking up from the bottom of the patient's head at a user-specified thin slice of the anatomy. The orientation of the patient is shown on the screen with the patient's right side on the left-hand side of the viewing window and the patient's left side on the right side of the window. In the window just below are coronal slices stacked anterior to posterior. In the window to the top right is the sagittal view of the patient with slices stacked vertically right to left. The coronal and sagittal orthogonal views were constructed from the axial images. There are three ways to navigate through these slice sections. You may move the mouse cursor to the desired plane and use the scroll wheel to move through one slice at a time as you advance through the volume. The slice interval may be adjusted by clicking on the Change Layout button in the control panel, clicking on the slice interval, and clicking on the desired layout. We will more closely examine Change Layout later in this video. Or you may left mouse click on the line cursor and while holding down the mouse's button, move the mouse until you arrive at a desired location within a corresponding orthogonal image. Dragging a red cursor line in either the coronal or sagittal view window will scroll through the axial slices in an inferior or superior fashion. Dragging a blue cursor line in either the axial or sagittal view window will scroll through the coronal slices from anterior to posterior. Dragging a green cursor line in either the axial or coronal view window will scroll through sagittal slices from left to right. Lastly, you may place the mouse cursor in the circle of the intersection of the line cursors, and while depressing the left mouse button, move the mouse to an anatomical location of interest. Two corresponding orthogonal views of the selected region will automatically appear in the associated view windows. When your practice received its initial hardware and software training, the staff was taught how to position a patient. Proper positioning is the patient looking forward, occlusal plane parallel, with no side-to-side head tilt. This would generally result in positional results that need no post-scan adjustment. However, we do not live in a perfect world, no matter how much we try to make it so. The patient may move just before the scan is taken, or positioning technique may be a little off. Invivo's reorientation tool provides us with a way to reorient the volume to correct positioning in each of the orthogonal views using reference lines. You may and should reorient the volume if the occlusal plane is not parallel or if there is head tilt. If you don't, measurement errors may happen. For example, if the head is tilted too far downward, any lateral measurements of a cross-section will appear longer than they actually are, which obviously would be problematic when measuring from the crest of the bone to the inferior alveolar canal for placement of a mandibular implant. We will take a closer look at this when we move to the ArchSection View tab. When the reorientation tool is activated, alignment arrows will appear in each viewing window. Let's begin by dragging the green cursor line to the axial's midline and the red line to the maxillary crowns to use for reference. Next, let's drag any arrow until the patient is looking directly forward. Now let's shift our attention to the sagittal view window. Scroll to the patient's right or left dental arch and drag the red line between the upper and lower occlusal surfaces. Now drag an arrow until the patient's occlusal plane is parallel, level with the red line. Lastly, adjust the coronal view until the occlusal plane is level with the red cursor line and the head is perfectly vertical, no left or right head tilt. The cranial base is a good landmark to use if an extended field of view scan was done. Click the orientation icon to save the changes. Click on it again to return to the original orientation. We'll see later there are orientation tools in the ArchSection and Volume Render View tab as well. Okay, let's continue exploring the rendering window. You may find that you need to enlarge the image for greater visibility. This can be done in two ways. First, move the mouse cursor to the desired image, press the Control keyboard key and left mouse button and move your mouse upwards. Move the mouse to the bottom of the screen to zoom out. To quickly revert to the default view, click the Reset View icon on the toolbar. The second way to enlarge an image is to double mouse click on it. Use the aforementioned directions to zoom in and zoom out further. You can navigate through the slices by using the scroll wheel. To return to the original view, double mouse click on the image again. You may find the need to move the image on the screen or pan the image. Move your mouse cursor to an image, depress the Shift keyboard key and the left mouse button and move your mouse. As with the zoom feature, you may click the toolbar's Reset View to return to the home position. The lower right area of the rendering window is reserved for displaying a 3D volumetric rendering, displaying the patient's airway for measurement, and for displaying custom sections of the anatomy. At this time, let me show you how to create a custom section, and we will explore 3D rendering and airways later in this video. A customized section may be created as a perpendicular or orthogonal slice to any cross-sectional view to better visualize anatomy along an axis. To create a custom section within a view window, begin by selecting Custom Section in the Control Panel, then clicking Create. I will scroll to the patient's maxillary implant site to demonstrate this. First, left mouse click a beginning and an ending point. Once created, the custom section will appear in the lower right viewing window and may be navigated by clicking and dragging any arrow to rotate 360 degrees around the selected anatomy. You may click and drag the endpoints to include or exclude anatomy viewed within the section. Or you may click and drag the center point to reposition within the anatomy to create a new section. Custom sections are quite useful for impaction or endodontic assessments. You may adjust the slice thickness to include more associated anatomy by clicking on either of the circular handles flanking the center of the section and while holding down the mouse button dragging the mouse. Or if you prefer, you may increase the slice thickness by clicking the slice thickness drop-down in the custom section of the control panel and entering a value. The sharpening filter can be adjusted for greater visibility of the tissue and cortical bone. Slice thickening creates views that are similar to intraoral x-rays. Slice thickening uses ray sum when reconstructing the 3D image along each orthogonal plane. This is accomplished by increasing the number of adjacent voxels, or three-dimensional pixels, if you will, included in the display, thus creating an image slab that represents a specific volume of the patient. For additional information regarding ray sum and CBCT in general, you may want to begin by Googling an excellent journal article written by Drs. William C. Scarf and Alan G. Farman entitled, "What is Cone Beam CT and How Does It Work?" Use Delete in the control panel to delete the custom section, then reset the change values. Now let's view a 3D volumetric image by initializing 3D volume in the control panel. To zoom in or out or pan the volume, use the procedures discussed earlier. Within the 3D volumetric view window, you have additional viewing features that are not available in the 2D viewing windows. These are free rotate, free rolling, and plane clipping. To free rotate, place the mouse cursor in the 3D viewing window, and while holding down the left mouse button, move the mouse in any direction to achieve the desired rotational position. To free roll, hold down the spacebar and the left mouse button and move the mouse up and down to rotate the image about a central axis. You may select Enable Clipping in the control panel to slice the 3D volume along predefined sagittal, axial, and coronal anatomical planes. To clip the axial plane, select Axial in the control panel. Let's drag a red cursor line until the mandibular canals appear in the axial view window. Now we'll rotate the 3D volume and drag the red line as necessary to view the desired anatomy. Next, let's select coronal and view the volume more posteriorly. Rotate the volume and drag the blue cursor line as needed to view the desired anatomy. Lastly, let's select sagittal and drag the green cursor line to the desired location. Let's rotate the volume to a sagittal view to see it in a lingual aspect. Let's drag the volume back to the front view and clip from the opposing side by selecting Flip. Flip may be used in the other two orientations as well. Click on Custom Section to delete the 3D view. Now let's learn how to trace an airway. First, move the intersection of the horizontal and vertical cursor lines in the axial view window to arrive at airway midway in the sagittal view window. You may use the mouse scroll wheel in the sagittal view window to make fine adjustments to the midline. Next, let's click the airway measurement tool on the toolbar. Left mouse click to place a point where you would like to begin your measurement and add points as you move through the airway. Right mouse click after the final point is placed. The profile tracing will be converted into a volume rendering, which will be superimposed onto the scanned data. An isolated airway may now be examined in the lower right view window. The minimum cross-sectional area and total volume are displayed next to the airway measurement. Graphs of the right and left and interior-posterior distances, as well as the cross-section area, are displayed. Individual values may be obtained by clicking on the graphs. The Setup View tool allows you to change colors associated with the volumetric measurement range, as well as threshold density limits of the airway. The airway volume and measurement values may be deleted by left mouse clicking on the airway, then pressing the Delete key on the keyboard. You may wish to customize the appearance of your rendering window by selecting Change Layout in the Control Panel, or on the toolbar you are presented with orientation options. For example, if you would like to have the axial view always appear larger than the sagittal and coronal views, select Axial plus 3 cross-sections. You may also change section view format to a light box style. The light box is composed of 4 to 32 sections of either axial, sagittal, or coronal views. You may also define the slice interval by selecting a value from the drop-down. Let's choose a 0.2 mm spacing between slices and 4 sections. Once changes are made to the layout, they will immediately be viewed and will appear the next time that you open a case. Use your scroll wheel to move through the slices. To revert to the original view, select Default in the Control Panel. In the View Control section, you may adjust the image's brightness and contrast. Click the mouse cursor over either toggle, and while holding down the left mouse button, move the mouse to adjust the image. You may click on a slider toggle and move your scroll wheel to achieve the same results. In the View Control drop-down of the Control Panel, you may select a color preset to allow for better visualization of certain anatomic structures, soft tissue profiles, airways, etc. The color rendering is only for visualization. The colors are based on densities but do not represent the density value of the bone. I find these presets more valuable when looking for a nerve canal in the ArchSection View tab. Directly below View Control, you may enhance visibility by applying a sharpness filter to the 2D slice renderers by clicking on the drop-down. Next, you may change the thickness of each slice within the view windows. This tool uses the previously discussed ray sum when reconstructing the 3D image along each 2D orthogonal plane. The 0.0 setting is actually the thickness of the selected voxel when the image is captured. For this particular scan, it would be 0.25 millimeters as shown in the resolution window of the image info screen of the control panel. You may also find information regarding the scan by clicking File on the menu bar, then clicking Case Info. Also in the Image Info section of the control panel, there is a summary of the dimension and field of view size of the scan. Within the pointer coordinate section of the control panel, you will find the most useful feature, the HU or Hounsfield unit window, which displays an approximate value of the bone's density. As you move your mouse cursor through the anatomy, the values will change. These approximations may not be as accurate if your CT hardware calibration is off, or if there is significant scatter radiation from denser material, such as restorations or implants. Contact your hardware manufacturer for more information about HU accuracy. Save View settings will be turned on when you first begin using your software. You see that its button is grayed out, which indicates this. Save View settings automatically saves the current 2D view settings and will be relocated upon opening any case. Among these settings are rendering presets, custom brightness and contrast, sharpen filter, volume clipping, and slice thickness. Please consult your Invivo reference manual for a complete list of the 2D view settings that will be automatically saved in the Section, Implant, ArchSection, and TMJ view tabs when a case is closed. If autosave were not activated, you would need to click the Save View Settings button each time that you would like to save your preferred settings. If you wish, you may manually save your view settings. Autosave may be turned off by going to the File drop-down on the menu bar and selecting Preference. Deselect Auto Save 2D View Settings on Application Exit and click OK. When we now look at the Save View Settings button, you will see that it is not grayed out and is active. Let's turn our attention back to the rendering window. In each of the four windows, the patient's name, birth date, and gender will be stamped in the upper left corner when the information display function is active. If the text is not visible, click the eye icon on the toolbar. In the bottom right corners, Invivo Dental and Anatomage, the engine that powers Invivo, are stamped. In the upper right corners, Anatomage appears again along with the date of the scan. You have the option to change all or some of the information appearing at the top left and top right corners. Let's first anonymize the patient information. We'll select File on the menu bar, then Case Info. Let's click Anonymize and change the patient's name, date of birth, and gender. Now let's open File, then Preferences, and replace Anatomage with your name or that of your practice. Type the changes in the tag text box and click OK. You will now see the changes reflected in each of the four windows. The information will appear upon printing or saving as an image file. I'm going to turn the text off for now. To change the cursor's visibility on the view screens, do the following. On the toolbar, click Toggle Cursor Visibility once to remove the cursors. Click again to put the cursors behind the images. Click again to revert to the original view. The toolbar has three measurement tools. The first of these measures distance. Click its corresponding icon to activate the function. Then left mouse click where you would like the measurement to begin, and left mouse click again where you would like it to stop. Left mouse click on the tool again to deactivate it. Let's double mouse click on the image so that we may have a closer view. To modify the measurement line, left mouse click on either red end point of the measurement, and while holding down the left mouse button, move the point to the desired location. To move the distance measurement text, left mouse click on it, and while holding down the button, move the text to another location. Left mouse click away from the text to lock in the change. You may change the text size by selecting File on the menu bar and then selecting Preference. You have the choice of large, medium, and small. Let's change to medium. While in Preferences, you may want to deselect Enable Multiple Distance Measurement Mode. If you choose to deselect this option, it will be necessary to click the distance measurement icon each time you want to make a measurement, but you do not have to click the distance measurement icon again to turn off the tool as you do with it enabled. You may also want to select Cycle 2D Distance Measurement Color. This option will enable 4 different colors to be cycled as you draw multiple measurements. It helps distinguish one measurement and its text from another. We can see the measurement text size is larger now. Let's delete the measurement by left mouse clicking on it and clicking the keyboard delete key. Let me make a few measurements to show you how the cycle colors look. The next measurement tool will define an angle. After selecting this tool, click the first point, then click the vertex, and then click the last point to create an angle. Degree of angulation as well as the length of the rays will be displayed. To adjust the angle, any of the red points may be clicked on and dragged. The third measurement tool will calculate the surface area of a slice. After selecting this tool, click multiple points along the boundary of the desired area. Double mouse click or right click to end the measurement. The area will be displayed in millimeters squared. Let's move to the annotation tools, which will give you the opportunity to draw attention to any details within a slice. The arrow notation allows for an arrow to be drawn on a rendered image. Just mouse click where you would like the staff of the arrow to begin, then move your mouse to the area of interest and mouse click. You may move the arrow by left mouse clicking on either endpoint and then while holding the button down, drag your mouse. Mouse click away from the point to lock in your changes. The circle notation tool allows you to circle an area of interest. You may add text by selecting the text notation tool. Click where you'd like to enter the text, then after the red Enter Text display appears, type your note. You may move the text by left mouse clicking on it, and while holding down the mouse button, drag your mouse to the desired location. The text and measurement color may be changed in Preferences. Also in Preferences, you may select Make Text Annotations Global, so text will appear on all slices as you scroll through them. The HU measurement tool calculates the Hounsfield unit value of an area within a bounding box, which may be dragged after it appears. The information updates when the box is moved or if the slices are scrolled. The measurements may be moved by clicking and dragging. The View Sequence tool on the toolbar allows for the creation of custom camera sequences and AVI file movie capturing. I will demonstrate this tool when we arrive at the Volume Render View tab. Let's now take a look at saving and printing the images in a viewing window. As example, I would like to save a custom section. There are a couple of ways to do this. Let me first create a custom section. Now let's select View on the menu bar and click Capture to File. I will select the save location, give the image a name, select an image type, and click Save. This will save the entire rendering window. You may retrieve the image whenever you would like to print it, share it, or import it to another software program, say like a practice management software. Rather than saving the entire rendering window, you may isolate one viewing window by double mouse clicking on it before capturing to file. The second way to save and print an image offers you more options and is generally the more preferred method. Click View on the menu bar, then click Capture to Gallery. In the dialog box, select an image to capture. Let's choose Cross. The Cross option will not be available whenever there is a 3D volume rendering or airway appearing in the lower right viewing window. If you wish, you may add comments and click OK. Open the gallery by clicking on the Gallery View tab icon. Let's select the image that was just saved. In the control panel, you may reorder, crop, or remove the images. You may export the saved images to a folder on the workstation or to a shared folder on your practice's computer network. And you may automatically attach an image or images and email them if you have either a Microsoft Outlook or a Mozilla Thunderbird email client. You may also print from the gallery. Click File on the menu bar. I would recommend that you first go to Print Layout Setup and change the background color to white. It will save ink. Let's select Print Preview to see how the image will look when printed. If desired, you may substitute your practice logo for the anatomage one. Call the technical support number you were given when you purchased your scanner, and they can help you with this. Before you close your scan, you will need to save your workup, or any changes you have made will be lost, including measurements, nerve canal markings, any implant or restoration planning, and saved images in the gallery. Let me show you one way to save your workups. Click File on the menu bar. Click Save As. You will be given several choices. Let's select Invivo, which is a proprietary file format only viewable in Invivo. Click OK. Next, choose a save location. Change the file name if desired. And click Save. Select Full and click Save. The next time you would like to view this scan and any changes that were made within it, simply double mouse click on the file and Invivo will open it. You will still have the scan saved in its original, unchanged DICOM file format. There are several other ways to save your workups and to set default save locations. These are covered in the Invivo reference manual. Let's now move to the ArchSection View tab. There are two main clinical features within the ArchSection View tab: the creation of cross sections and nerve tracing. Let's begin by looking at the layout of our rendering windows. The default screen layout of the rendering window includes axial, pano, and 3 cross-sectional views. This format is the generally preferred layout of the doctors I have trained on the software. However, if you would desire something different, click on either the Change Layout button located in the control panel or the layout icon on the toolbar. The axial, pano, and 9 cross-sectional views is popular as well. For this video purposes, let's keep the existing format. Depending on the field of view used when the patient was scanned, it may be necessary to adjust the upper and lower limits of the pano and cross sections to see the desired anatomy. Let's click on the Adjust Range and Orientation in the Control Panel. Here we may not only change the upper and lower limits, but we may reorient the volume as well. If we reoriented the volume in the Section View tab, it would not be necessary to make any adjustments here. For example, if the occlusal plane is not parallel, there could be measurement errors when viewing the lateral distance of available bone in the cross sections. The distance measurement would be calculated on a more diagonal plane, indicating more bone than what is truly available. To reorient the image, click and drag the red rotation widget until the blue arrow is on the same plane as the occlusal surfaces of the upper and lower arch. If necessary, the axial and sagittal positions may be reoriented by free rotating the volume and dragging their respective widgets. Next, let's look at the lower left volumetric view to see if the desired anatomy is between the upper and lower limits. If not, click on and drag either green line to make adjustments. Deselect Adjust Range and Orientation when finished. Drag the red horizontal line in the Pano window to scroll to an axial slice that contains the desired anatomy, or you may move the mouse cursor to the Axial View window and use the scroll wheel. In the Axial View window, we find 3 green cross-section indicator lines. The arch location in the 3 cross-sectional view windows correspond to these lines. When the lines are moved along the arch, the cross-sectional views will change based upon the line's new locations. These lines should be perpendicular to the arch. If the lines are oblique to the perpendicular planes, buccal lingual measurement errors may occur. The distances would appear longer than they actually are because you would be measuring in a diagonal fashion. To adjust the line angulation, simply left mouse click on the points within the desired anatomy and drag them to the middle of the arch. Once the lines are perpendicular, your measurements should be accurate. While the SuperPano View tab offers more features when creating and viewing panoramics, panos may be created in the ArchSection View tab as well. Let's go ahead and create a pano from the volumetric 3D data. First, move the red cursor line on the pano to the canal level of the mandibular teeth as seen in the axial view. In the control panel, choose X-ray, mild or hard sharpen filter, and adjust the brightness and contrast for better visibility. In the Axial View window, adjust the focal trough by dragging the points to the middle of the arch. If you do not see all the posterior anatomy desired, click and drag either of the 2 inside points downward. The changes will be reflected in the Pano View window. A new focal trough may be created by clicking on the Create Arch Spline tool on the toolbar. Arch Spline is synonymous with focal trough. I personally like this feature because I find mapping the trough is easier with more points. More points may also make it easier to mark the nerve canal. We will begin by moving the mouse cursor to a starting location, left mouse click to create a point, and continue along the middle of the arch until you reach the most posterior point you would like to include. Then right mouse click or double left click to finish. You can then tweak the trough as we previously did by moving the points. The pan we just created was based on the mandibular arch form. Because of this, the upper arch may fall outside of the limits of the focal trough, causing desired anatomy not to be included in the pan. Scroll to the maxillary arch, and if any portion falls outside of the arch, you may move the points as before. Additionally, you may left mouse click on any of the 4 outside points, and while holding down the mouse button, drag the points horizontally until the trough is wide enough to include the anatomy. Now that we have created a pan, let's trace the inferior alveolar nerve. Let's begin by selecting Slice in the control panel. Next, move the Pano red cursor line until the canals of the mandibular teeth appear in the axial view. Next, resize and move the Pano image as necessary until you see the entire mandibular arch within the viewing window. You will want to clearly see the nerve canal in the Pano View window. If you do not see the entire canal in the area of interest, move the points in the axial view buccally or lingually until you do. You may need to adjust the brightness, contrast, and sharpening filters for better viewing. If the canal is still hard to detect, you may want to try using a color preset. Use the mouse scroll wheel in the Pano View window to make fine adjustments. Once the canal is clearly defined, drag the vertical green cursor line towards the middle foramen until you see the nerve exit in a cross-sectional view. Click on New Nerve in the control panel, select the diameter of the marker if necessary, and mouse click to set points as you navigate the superior border of the canal. If you place a point outside of the desired area, click Delete in the control panel, and the last node will be removed. Continue to follow the canal until you reach the vertical green line, then click on the nerve exit in a cross section. Right mouse click or click Done in the control panel to complete the nerve mapping. The mapped nerve will now be visible in this view, the SuperPano View tab, as well as any of the 3D view tabs. To delete the nerve, left mouse click on it and click the keyboard Delete key. Additional information regarding the creation and editing of a nerve pathway is available in the Invivo reference manual. Let's now take a look at the control panel features. In the cross-sectional area, we can change the width, interval, and thickness of the slices. Width will modify the slice's buccal lingual length. Interval changes the distances between the subsequent cross-sections, and thickness allows for the cumulative thickness of the slices to be viewed in the cross-sections. The auto right and left setting allows the cross-sections to be oriented to a consistent right-left orientation on the screen. If turned off, the cross-section orientation will be consistent to the arch spline. In the panoramic image section, slice mode will show you a single cross-section along the panoramic curve, the middle line of the focal trough moving through the arch. This type of multiplanar reconstruction is known as curved planar reformation. X-ray will show the ray sum reconstructed X-ray in the focal trough. When X-ray is selected, you may turn on or off a horizontal ruler that appears under the pan. Moving to the toolbar, we find new measurement tools. The arch spline ruler places a ruler along the arch spline or focal trough for easy reference. The distance between each tick mark on the ruler is 1 millimeter. The second new measurement tool is polygonal measurement. When this tool is selected, you may mark an unlimited number of points on the volume. The distance between the first point and the last point will appear. Right-click your mouse to indicate that you have marked your last point. Clicking on the point and moving the cursor can modify the points and the distances. Slice capture mode is a utility used with the Report View tab and optional module. Before we move to the SuperPano View tab, let's take a look at Layout section of the control panel. Screen layout is the default view and is optimized for viewing the image on a computer screen. Printout layout is optimized for printing. With the printout layout activated, what you see on the screen will be printed on the paper as life-size. To print, capture to gallery, open the Gallery View tab, then use the Print function in the File drop-down. Let's move to the SuperPano View tab now. This View tab gives you the ability to construct and view an enhanced version of a panoramic radiograph, take measurements, and utilize several image enhancement features. It also has the ability to render a pano into a volumetric 3D image that can be rotated for greater visual advantages. To create a pano, let's begin, if necessary, by setting the upper and lower limits on the coronal view to include the anatomy we want to appear in the pan. Next, modify the sizing or placement of any views as necessary for better visibility. Select Slice Mode, which is located at the bottom of the control panel. Drag the red line to just below the CEJ of the lower central incisors. Next, adjust the points in the axial view by left mouse clicking and dragging them so that they are in the center of the arch. Click and drag any of the outside points to widen the focal trough, as necessary, until the entire arch falls within the outside borders of the focal trough. If all of the desired posterior anatomy does not appear in the lower right window, extend the focal trough by clicking on either of the lower middle points of the focal trough and move your mouse posteriorly. As you make these changes in point placement, check your work in the lower right pan view window. If needed, you may choose to create a new focal trough on the axial view as discussed in the ArchSection View tab. You may move the entire focal trough by left mouse clicking on the line, not a point, and while holding down the mouse button, move the mouse. If the roots of the maxillary incisors appear unnaturally curved posteriorly, you may want to move the points to flatten the curvature of the anterior position of the focal trough. Once satisfied with the lower arch, drag the horizontal line to the maxillary arch. If any of the dental arch falls outside of the focal trough, widen the trough to include the dental arch. Next, slide the grayscale threshold toggle in the control panel to filter soft tissue so that the Pano preview image in the lower right viewing window is neither too dark nor too light. Click Create Pano in the control panel. The pano may be rendered in multiple visualizations. The default Enhance Gray in the View Controls section of the control panel sharpens grayscale rendering. The image may be enhanced by changing the brightness and contrast or by applying a sharpen filter. Inverse switches the background to white. The SuperPano View tab is not limited to 2D grayscale images. By choosing among the different options in the control panel, you can create a pano based on a 3D volume. Let's select Composite 2, Enable 3D, and Quality. The pano will become a fully rendered volume, allowing you to freely drag, zoom, pan, rotate, and clip the image. A trace nerve or a virtually placed implant may be toggled on and off in the nerve and implant boxes. The grid application on the toolbar toggles between 3 different grids within the 2D panoramic view window. The default transposes vertical and horizontal rulers that has tick marks with 5 mm spacing. A click of the grid icon will overlay a grid with cells 10 mm squared. Click again, and rulers appear again with 5 mm between the tick marks. The rulers will now be shorter than the default ones to accommodate printing. Now let's move to the remaining View tab covered in this tutorial, Volume Render. The Volume Render View tab shows the patient in 3-dimensionally reconstructed views and allows you to explore the internal structures and never-before-seen views of the patient. Volume Render offers additional viewing navigation features. You may use incremental rotation by clicking on the keyboard arrows to rotate the 3D model 1 degree up, down, right, or left. On the toolbar, there are applications that will reorient the volume positioning automatically. By clicking on these icons, the volume will be reset to a specific orientation. There is a quick zoom tool on the toolbar that will enlarge the volume but keep an area of interest as the focal point. After clicking on its icon, move the mouse cursor to a desired location and mouse click to zoom. Use the Reset View icon to go back to the default size. To the right of Quick Zoom is the Quick Slice Explorer. Once activated, click on an area of interest on the volume to open a 2D zoom window. The slices in the zoom window may be scrolled by using the mouse wheel. The Explorer may be moved by mouse clicking on another area of interest. To turn off the Quick Slice Explorer, click the keyboard Delete or Escape keys or click on its toolbar icon. Now let's take a look at the sculpting tools. The sculpting tools are very helpful for isolating a particular area of interest or when removing surface artifacts such as scatter for presentation purposes. Clicking on Freehand Sculpture will allow you to freely outline an area and remove the volume perpendicular to the plane of the screen. Place your mouse cursor where you would like to begin, click and hold down the mouse button, and drag your mouse to the ending location. The volume inside or outside the selection can be chosen for removal by clicking in the respective areas. Be sure to curve the sculpting line toward the area to be removed. The Polygon Sculpting tool will outline an area when you place a series of points and right-click when you are near the first point to enclose the desired area. The volume perpendicular to the plane of the screen will be removed. The volume inside or outside the selection may be chosen by clicking in the respective areas. To restore the full volume, open Edit on the menu bar and click Undo. You may also use an undo shortcut by holding down the Control keyboard key and clicking Z. Before we take a look at other toolbar applications not available in the previously discussed view tabs, let's shift our attention to the Control panel. You may select from among 3 different methods of image rendering. In the method drop-down, performance is fast, but there are some rendering artifacts. Quality gives the highest level of detail, but response is slower. Default is in between the other 2 options. My advice to you is to try them and see which works best with your computer. The other available rendering method consists of volume rendering, the default setting, maximum intensity projection, and X-ray. Generally, you would probably want to leave volume rendering as the default, but maximum intensity may be used to highlight denser anatomical structures, creating a high contrast image. In View Control, we have color presets which may be used for better visualizations of certain anatomical structures such as soft tissue profiles and the airway. This is achieved by displaying specific densities with specific colors. Generally, you would use the default setting of teeth most of the time. You may personalize and create a new color preset. Select Set Custom. Shading of the volume can be changed by moving the arrows along the top and the opacity by moving the nodes in the grayscale scaler window. When you're finished, click Set as Custom. Now when Custom is selected while viewing a case, your personalized filter will be applied to the volume. If you would like to use the filter on other computers running Invivo, click Save as File to a shared folder locally or on the network or to a USB flash drive. When you have opened Invivo on another computer, open Set Custom, click Load File, and after clicking on the Save filter, click Set as Custom. As in the Section View tab, clipping capabilities are available in the Volume Render View tab with the addition of several new features. To clip within the Volume Render View tab, activate Enable Clipping, left mouse click on the slider toggle, and while holding the mouse button down, move the mouse. You may also put your mouse cursor over the toggle, push the scroll wheel down, and spin the wheel. Another new feature enables you to adjust the size of the volume that is not clipped from a 5mm slab of slices to 1/2 of the volume. You may also clip around the center axis of the arch. Let's shift our focus back to the toolbar. The volume measurement interface allows you to estimate displaced volume in cubic centimeters or millimeters of a specified anatomical structure. This function is explained in the Invivo reference manual in a section entitled How to Create a Positive Airway View. The airway measurement tool also shows a positive airway view, which is color-coded based on area. This inverse method lets you see the airway without color coding. It is a much easier tool to use for airway assessment than the volume measurement tool. The airway measurement tool measures the airway volume as the section view tab airway measurement tool does. When you click on the application on the toolbar, the volume is automatically placed in a view that is clipped at the middle of the volume rather than the manual method required in the section view tab's airway measurement tool. You may have to still tweak it some by moving the scroll wheel. Let's go ahead and mark the airway. When the right mouse button is clicked, the airway's total volume and minimum area will be calculated and displayed on the screen. Switching back to the Section View tab, you see that the airway was marked here when it was marked in the Volume Render View tab. Not only will you have total volume and minimum area calculated, but the right and left and interior-posterior distances and cross-sectional areas are calculated as well. Once the airway is calculated, you may turn off clipping and select a color preset. The airway is now displayed with the entire volume. To delete the calculated airway, click on it and click the keyboard Delete key. The Comment Marker tool allows you to select a point in the volume and enter annotations. Enter the text you would like to appear in the Insert Comment window and press OK. Multiple annotations may be added. The text will follow the selection as you move the volume. In the Annotation section at the bottom of the control panel, you may edit an annotation. Simply click on the screen text and then type your changes. You can toggle added comments on and off by selecting Visible. Layout allows a sorting of all added comments in the rendering window based on selected setting: horizontal, stick to point, user dragged, vertical, vertical even distributed, or vertical round distributed. Let's shift our attention back to the toolbar. By clicking on the Quick Measurement tool, a ruler will be placed at the cursor tip so it may be dragged to an area of interest for a quick assessment. Click again to turn it off. A grid tool allows you to toggle between 4 different grid layouts for simple assessment of size, measurement, and spatial location. The Reorientation tool provides the user another way to orient the volume through each orthogonal view using reference lines. It also provides a method in the program to reset the volume to the default coordinate system after reorientations are made in the section, Volume Render, ArchSection, or TMJ View tabs. Let's begin by selecting Sagittal and dragging the yellow reference line between the occlusal surfaces of the maxillary and mandibular molars. Next, let's drag any rotation handle to rotate the volume to match the reference line to achieve a parallel occlusal plane. Let's continue through each view until the desired orientation is achieved. When finished, click Close to lock in the changes. By clicking on the Setup View icon on the toolbar, you can set threshold and display color range preference for airway measurement. There are also options to view either parallel or perspective views in 3D. By changing these 3D options, you may show your patients their anatomy in an exciting way using camera projections. Before I show you this, I am going to clip away the spine to allow for better visibility of the teeth. Let's select Perspective and enter 5" in the Source to Patient window and click OK. Now, while holding down the Control keyboard key, left mouse click on the bottom of the rendering window and move your mouse up until you have moved into the oral cavity. You may change the color preset from teeth or change the opacity, brightness, or contrast for greater detail. Now you may navigate within the volume. To return to the default view, click on View Setup and change the projection back to parallel with the 60" source to patient. Click OK. And lastly, select Reset and Front View. The Volume Render View tab, like the Section View tab, has a view sequence application. This tool enables you to create your own view sequences by clicking on Insert for each step you want the volume to move. By using the video capture function, you will connect the positions in a seamless movie. You can integrate multiple different rendering presets so that it switches not only in sequence but also in colorizations. Let me insert a few frames to build a sequence. I think that would be enough for you to get the general idea. I will click Start to begin with the first frame and click Play. That's much too fast for me, so I will add more frames between each insertion point to slow the video down. You may also select Loop to play the video repeatedly. Okay, that's better. We can click on Save if we would like to install the sequence on other computers that have Invivo installed. Just pick a folder or create a new one, name the sequence, then click Save. You can save the sequence to a shared folder locally, or on another computer within the network, or to a USB flash drive. On the computer you wish to upload the sequence to, simply locate the .vseq file and click Load. Well, let's go ahead and create a movie of this sequence. Begin by clicking on Video Capture. You may accept the default save location or browse to another folder. You may accept the default codec or select a different one. For those of you that might not know what a codec is, it is a program that compresses data to enable faster video or audio transmission. I would recommend accepting the default unless you have playback problems, and then you might want to try another one. Set the frames per view and frames per second to a desired value. More frames per view will make the video smoother. More frames per second will make the video run faster. You may add a logo to display at the end of your video by selecting Add Logo. A picture of your practice, staff, or logo works well here. Set the duration and background color. Click Capture once everything is set up to automatically produce and export the video to a specific location with a specified name. Let's take a look at the video we just produced. The video has been saved as a .avi file and is easily shared. This completes an introduction to Invivo. You are well on your way to mastering the software, or at least the aspects of the software that you will use as you case plan and communicate with your patients. Thanks for joining us today. Do not hesitate to call technical support with any software questions or concerns that cannot be answered in the Invivo reference manual.